Hey everyone, good to see you all here. My name is Vikrant, and thanks for the introduction. I don't have to do the intro myself. But great energy, and I've been talking to a lot of folks. Just keep that energy for one more hour. Oh,
This here, and then this can just go in your front pocket.
oh, thank you.
Yeah.
Yeah, keep that energy for one more hour, and let's go through some quick agenda. First, we'll talk about some of the US bank payment rails like ACH, wires, and probably the new ones like FedNow. And we'll go through what is reconciliation for bank payments. What do you mean to reconcile transactions and settlements? And some real world use cases with ACH and wires around payment systems on Temporal. And we're not going to talk about building systems, but we're going to talk about building platforms. So new use cases or new workflows or new payment rails coming in should be able to leverage those platforms. And obviously some takeaways that you'll go away with. All right, so what are some of the bank payment rails we have today? So ACH, wires, these are very popular. I'm sure you use ACH on a regular basis. The paychecks that you get on your Fridays or weekend or on your month end is ACH. And wires, I'm sure you have done like home transactions, or when you bought a home, you did a wire transaction or international wire transactions. And FedNow is relatively new. FedNow is like, if you have been to India or China, it's like UPI or WeChat. So it's not WeChat, I mean Alipay. So FedNow is relatively new, but it is something that Fed is working on. It's a recent launch in July 2023. So just to give you a high level, today all the interbank payments are going through Fed. You cannot do a direct bank-to-bank transfer. You have to go through something like Federal Reserve. So in this case, for example, let's say Alice wants to send some money to Bob. Alice will talk to her bank, and the bank communicates with Federal Reserve via files, and those files will be sent to the respective banks, and that's where the transactions are complete on the other side. All right, so ACH, let's talk about some of the properties of ACH. We all know ACH is, again, something that we use on a regular basis. A lot of P2P are using ACH. So first property is it's not real time. Like that's not instant in the sense that once you do a transaction, it's not going to be instant. And it's a batch process. Just like I said previously, when the bank sends a transaction, it is actually sending as a file to Fed. That means it has a bunch of transactions that it is sending, and those batches are being sent to Fed, and Fed is again segregating those transactions and sending into respective banks for all the credits and debits. And obviously it's not instant, so it's cost effective, it's cheaper. And there is an option for reversibility. Like for example, if there is an unauthorized transaction, you can go to your bank and say this is an authorized transaction, and they will get you a reversal for your money. And all these transactions in ACH has Fed oversight. That means customers has rights, banks have rights. So as a customer, if you see an unauthorized transaction, you have until 60 days to contest or dispute the transaction. Same thing, if bank makes some mistakes, they have like 5 days to do a reversal. And some of the things that you see with overdrafts are with those reversibility as well. And ACH also can be done internationally, so we call them IATs. And every transaction goes through fraud and AML checks on anti-money laundering checks. Those are something that is required for being regulatory. And recurring and paychecks, a lot of bill pay, recurring paychecks are all something that ACH supports. All right, let's look at some ACH stats. In 2022 alone, there were 30 billion payments and 10 million per day. And you can imagine on Fridays, because you get your paychecks, it's 50 million. So there's $79 trillion of ACH transfers that happened in 2022 alone. The reason I'm bringing up this stats is we as developers or teams, we have a responsibility to build the systems right and build with resiliency and make sure they're correct, because there's a lot of onus on us when you see these numbers. All right, let's get to some wire transfer properties. Just like ACH, there are some commonalities, but we'll go through them later. But wire transfers are mostly real time. In the sense that sometimes they might take a day, because if you're hitting some anti-money laundering checks or bank needs to do some extra oversight, then it's not going to be real time, but mostly it's going to be on the same day. They're irreversible. That means once a bank gets other bank gets the file, then it's not really something that we can do to reverse the transaction, unlike ACH. And there's always some fee involved. I'm sure you might have paid those $15 to Chase and Bank of America when you do these wire transfers. And there is also Fed oversight, in the sense that there are some regulations around how these wire transfers should be done. And wire transfers also have international, wire also support international transfers. I'm sure most of you have done like international wire transfers if you haven't. And just like ACH, there is anti-money laundering and fraud checks that banks do when these transactions come in. Some stats, it's not as big as ACH, but if you see it's growing almost 3 to 5% every year. There were 200 million payments in 2022 alone in the US for wires, and $1 trillion have been moved in wire transfers. And the next one is FedNow. FedNow is relatively new. It was launched on July 2023. July 2023, and it's real-time instant. Not a lot of banks are using it right now, because it's still in a nascent phase, and every bank is going towards this rail to do instant money, to support instant money movement. But some of the properties are it's available 24/7 because it's instant, and it's domestic. So currently it's domestic only. And one interesting thing about FedNow is it's going to support instant settlement with banks. If you don't understand it, we'll get some examples next, so don't worry. But for the rest of the talk, we're going to focus on ACH and wires, but the same principles apply for even for any money movement transfer like FedNow or Zelle or P2P, any P2P. Okay, let's switch some gears and talk about reconciliation. Reconciliation is think about reconciliation as verifying your transactions, right? So let's say you have a few systems that you're involved with, where you are doing money transfers. Like there's a money movement system in your company that you have that is dealing with money movements, and you're dealing with Fed, that is one vendor, and money movement system is another vendor. And now you want to reconcile. That means you want to verify the transaction that Alice sent. Let's say $100 is equal to what you see in all the systems that the transaction is going through, right? So reconciliation is as simple as verifying. So to give you even more simpler example, you get these bank statements every month. When you get your bank statements, you look at what is your balance, what are your transactions, and go look at the UI to verify sometimes what is your real balance and what are the transactions. I mean, if you're a partner like me, of course. But if you do that, that is nothing but reconciliation. You're looking at your bank statement and you're looking at your ledger, which is the UI, which is fetching the data from the ledger. That is simple reconciliation. And also I went to SoFi back office to get an industry definition of what reconciliation is. So the paragraph that you're seeing on the screen is the industry definition of what reconciliation is. If you don't get it, don't worry. I also did not get it when I read the first time. But if you look at it, there are two parts to it. One is reconcile incoming files against a ledger to confirm the transactions are posted successfully. That's the first part. And the second part is confirm against funding in the banking statement. So let's dissect this an example. Okay, so there are two kinds of reconciliation. One is transaction reconciliation and other is settlement reconciliation. So let's say you have a transaction, and this is the image you see is an ACH file that comes in from Fed to a bank. And if you see there are two transactions here, one for Benjamin Franklin and other is George Washington. So there are two transactions. Now, the first transaction, let's say of Benjamin Franklin, will come through Fed. That's a transaction, and that will hit one of the money movement system, which needs to update the ledger, right? So now you need to verify that $100 that Fed sent is actually a credited or debited to the ledger. So you reconcile the transaction to make sure the amounts are matching. So that is a transaction reconciliation, like it's one-to-one. Whereas settlement reconciliation is, now for example, if you see the picture, you see a total credit and total debit, right? That is the total amount that the ACH file is gonna debit or credit from the Fed master account of the bank. So bank holds an account with Fed, and that amount needs to be debit or credited. Now that amount needs to match with what is in this file. So this is a settlement reconciliation. Think of it as a batch reconciliation. We are looking at the full batch and getting the total and verifying what is being debited or credited from your Fed master account. So I hope you understood what transaction and settlement reconciliation is. It's transaction-based, and other is a summary or a batch-based. All right, why do you need reconciliation? Why does a bank need reconciliation, right? So one thing is bank needs to keep their books clear. Every penny needs to be accounted for. So financial records accuracy is one important thing that why you need reconciliation. And there's a lot of unauthorized transactions that happen. Banks are always at risk of hackers coming in and trying to take their money. So fraud detection, like if you have something happens, reconciliation is a system that determines or detects these problems or in your books. And compliance, bank needs to be regulatory compliant. They need to make sure they adhere to these tax laws and standards. So compliance is one other reason why banks will do reconciliation. And liquidity, it's not directly related, but based on reconciliation data, banks can make informed decisions of whether they want to invest their money or do something with it. And from a software standpoint, we need to validate your end-to-end systems. Like when you get a transaction, you're hitting multiple systems. And all these multiple systems needs to be doing this transaction once, not twice, for example, right? So your SLA is coming to picture. So when you build your systems, you talk about, I want to provide 99.29 of SLA or 11/9 of SLA, whatever. But in payments, you need to be 100% reliable. There is no, you can't miss even a single transaction out of 10,000. You need to make it reliable. So reconciliation is that system that provides you that 100% reliability, which will detect those failures or detect those double payments, and you can credit or debit back to your customer. And obviously, the most important one is customer trust. If you make a double payment, or if you lose sending a payment to one of customer's customer, then you're going to lose their trust very quickly. So it's important to be reliable, and reconciliation will provide you that. Okay, so let's talk about some reconciliation processes. Maybe I'd not introduce you to back office. So what is back office? Back office is like when you go to a physical branch, right? You talk to the personnel there, you talk to the people there, but back office literally sits in the back office. Backside of the office, I mean. They take care of reconciliation, administrative stuff, etc. So what does reconciliation process mean for back office? How does it work? So mostly, a lot of banks, they're still on spreadsheets. They often deal with they do it manually and deal with spreadsheets, which is obviously error prone and not recommended. And the first thing they do is match these transactions. Match transactions. It's painful, but that's what they do. And they look at, did they get all the transactions? Did they get all the settlements? And they verify these transactions actually match, and create reports for reconcile reports and also exception reports. When they have exception reports, they generally do post follow-ups. Post follow-ups come in with either engineering teams or maybe third parties. Okay, with that context, let's look at what we have learned so far and what are some of the commonalities with ACH, wires, and reconciliation. So you have inbound and outbound payments. Both ACH and wires needs to be sent to Fed and also received from Fed. And wires and ACH are files. Basically, these are batch processes. That's what we learned. And there are some anti-money laundering and fraud checks that are happening on these transactions. So that is one more commonality. And there is reconciliation on all these payments. So reconciliation is a must on all these payments. So one thing I would emphasize is, don't build products, but build platforms. That means you have a new payment rail tomorrow. You should be able to use these systems and use these commonalities to your advantage and build your use case or rail on the same platform. Okay, with what we learned so far, we have 3 platforms, because now we are going to go from systems to platforms. We spoke about files that are being sent and received from Fed. And we spoke about money movement, in the sense money needs to be applied to the of customers. And the third one is we spoke about reconciliation, reconciling the payments. So if you build a conceptual model around these at a very high level, what you will see is there's a feed platform, that a gateway to Fed, that is doing parsing. As you get these files, you need to parse these files, and then you need to transform these files into the downstream formats, and then send these files to your downstream, dispatch these files to your downstream. So there is a parse, transform, and dispatch. So that is the feed or file gateway platform that you can see. Another conceptual platform is a money movement platform. So far we have spoke about the commonalities. One of them is validations. Validations with AML services, or validations with your ledgers to look at your balances. So validations is one aspect of your money movement platform, and then you need to post your transactions to your ledgers. So that is a second conceptual platform that you can think of. And the third one is obviously reconciliation. Now it needs to work with both of the systems that we have, file gateway and also money movement, to reconcile everything, that whatever the first system and the second system sees is what is equal, and they agree in every way. I hope this is clear so far, and let's get to some, because this is temporal talk, and we are going to use temporal to build these platforms. I don't want to sound like a broken record, but these are even more important when it comes to payments. Things like resilience, because you have to be correct, and you have to make sure you're reliable and available, and so that is super important. Scale, temporal give you scale. You can scale up your workers up and down, and most of the payments are on weekdays. So, and auditability, you want to see what really happened and maybe store them for 7 to 10 years. And state management. Obviously, some of the platforms that we discussed are storing some state and then dispatching and moving transactions. And the second order temporal benefits are, it has a dev-friendly programming model. Developers can onboard easily. And one other interesting aspect is it can support crons. Like I've spoken about inbound payments, but if you think about outbound payments, when customers want to send money outside or through the bank, you can collect these in a database or some data store, and then schedule this job once every, let's say, 3 hours, based on what the Fed schedule is. So you can write these cron jobs as well, one of the benefit of temporal. And obviously, when you work in a tech company, a software company, all this is not done by a single team, but there are multiple teams involved, multiple tech teams involved, and temporal help you have separate responsibilities between teams. That you can create your own activities or child workflows in different teams. All right, so let's see how we can build a files platform. Maybe I'll go here. Okay, so let's take an example. Fed is sending you ACH file. Now ACH file has a bunch of transactions, and these transactions, think about, so I'm not prescribing anything. It's more about thinking about the steps that are involved in this diagram, and see why temporal is beneficial, or why it is better to build a system like this on temporal, or how it helps. So the 3 aspects, as I said, one is you need your parser, you need your transformer, and you need your dispatcher. So when you parse your file, you need to do things like duplicate checking. That file may be coming in, second time because of some bugs or errors. So you need to do some kind of duplicate checks on those files. Generally, I would look at the SHA-2 of the file and verify if it's a duplicate or not. And the second thing you need to do is actually parse that file. The parsing, every format is different, like NACHA is different, ACH is different, wires are different. So you need to parse these files. And then when you parse these files, you convert it into something, a general purpose domain model, When you do that, you will be able to create a platform. That means a new rail coming in, you can fit that file or transactions into a general purpose domain model. But is it easy to build a general purpose domain model? I think it is, because think about what you see in a transaction. You have a sender, receiver, you have account ID, you have amount, a credit or debit. So you can tease out all the common pieces together and build a data model. And maybe there is some custom data that is specific to these formats, which you can put into a custom data and write it into a database. That way you can create a queryable data source. Now what happens, what advantage do you get if you create a queryable data source? Now you can store it for a longer time. You can maybe stream it to a Snowflake or some other analytics platform that you can keep it for a longer time. Now Temporal will help you order these things together and build it. For example, you have to do your parser somewhere else, or in an activity or a child workflow in a different team. So you can do that. Temporal will provide you those advantages. And on the transformer part, now you have a transformer, you need to fetch the data from your database and fetch your customer IDs, because you don't want to pass in your account IDs, account numbers across your systems. So you fetch your information from the database and then you convert it into a list of files or transformers based on what your end system needs, which you can write to S3 buckets. And once you do that, the third part is obviously dispatching. Let's say money movement system needs JSON and recon queue requires some kind of XML. Your dispatcher can dispatch the transactions one by one as an activity. You can add your own retries, idempotence keys, for example, so you don't double post your transactions, and go from there. So, and what Temporal is giving you that advantage of state management, resiliency, and all those things. Okay, now the transactions have been sent to the money movement platform. Now money movement platform is receiving these transactions. Let's say the first transaction comes in. The first transaction comes in and you need to do some validations. Obviously the validations are against your ledger in terms of what is your balance. Can you do post this transaction? And also the next steps are some kind of fraud and AML checks. So if you have a fraud team that you can do a REST API or do native temporal calls. And a lot of times when you're doing these AML checks or anti-money laundering checks, you have a manual operator involved. If there is a AML hit, that means someone has to manually clear that AML hit and then pass it to the money movement system. So if you look at, there is a AML service, obviously that will be abstracted from your system. You do these calls and you can do things like polling or pushing. Just for simplicity, I just did polling. So temporal parent workflow can poll against the AML service and check if this is cleared. Now, sometimes it takes days or months. Now, obviously, temporal will help you keeping that for longer time. And I'm sure you have seen other talks as well where you can keep the state for longer time. And it is, once it's clear, then the parent workflow will take over and then credit or debit to the ledger. Once you do that, then you can do things like notifications to your customers and notifications to reconciliation service. Now, reconciliation service is something that we spoke about, and we're going to talk next. But when money is credited or debited, customer needs to know. So you can add hooks to notify your customers or write it to some queues, which will be sent as notifications to end users. Okay, now we learned about two platforms. This is the third platform. This is the system that reconciles everything. So we know there are two systems that are sending reconciliation events. One is the files platform, and other is the money movement service. Now you can create a abstraction. You can create a queue. So temporal workflows can read from that queue, and queues you can make sure you can guarantee at least once. So when you get these, again, you can do things like storing to your database, so you know exactly what is being coming in, and you can keep it for audit. And as I said, recon platform involves two things. One is matching your transactions. So when you match your transactions, you have something like transaction IDs or recon IDs that you can match against. And so if it's a fresh transaction, let's say you have a fresh transaction coming in from a system, then there is no existing match, so it will create a workflow that can do state transitions. The first workflow can be, let's say, in init state, and the second state transition that is coming in will match with the previous transaction ID and advance the state to, let's say, in progress from init. And the last, let's say there's a last transaction, last candidate that comes in to the system, and it matches with the existing transaction. And once you receive these three transactions, then workflow can do, is it reconcile? Does all the systems agree that $100 is being transferred from, let's say, Alice to Bob? If yes, then you're going to change the workflow state to reconciled, or else you're going to go put it into some kind of manual queue where back office or operators can come in and look at what is happening and work on those exceptions and then manually reconcile it. So yeah, so this is a reconciliation platform. So let's switch some gears. We have been talking about platforms, but if you forget Temporal, what it takes to build your platforms, you generally apply your OOPS concepts, solid principles, like dependency inversion, single responsibility, or open closed. And when you build your platforms, you always build for a specific use case, but you build it generic enough so new use cases can be onboarded, right? And platforms needs to have strict governance. That means access control needs to be there, traffic shaping if that's required, throttling, etc. And security is super important when you're building, at least for payments, encryption at rest and encryption in transit. You need to take care of it. And you need to separate your technology and business code. What I mean is, for example, if I'm using Temporal, I don't need to leak the abstraction to the onboarders or use cases of my platform that I'm using Temporal. They should be able to make it more, maybe they write some enums, or maybe config-based event that is better. And obviously, every platform aims, the North Star of every platform is they want to be configuration-based platform. Like someone comes in and writes some kind of YAML, and they should be able to onboard. But that's not something how you start your platform, building your platform, because that is hard. If you shoot for your North Star from day one, it's not going to work out, and it's going to be complex to build and design. So the way, at least when you build platforms, the way you start is make the bare bones work. Have some kind of onboarding doc where someone can write and someone can come and look into what classes they need to create, or what integration points or what hooks are you need to work on. But configuration based is something that you always think about as your North Star, as a long-term thing. Okay, now what are some of the things that you need to think about when you're building platforms with Temporal? One is, the first one is obviously delegate. There are activities and child workflows. The same concepts apply. If you think about single responsibility principle, right? Activities, if you're talking, one of the activities talking to DynamoDB, it should only be doing that. If it's mutating DynamoDB, let it do it. It should not add, don't add more responsibility to it. So keep the same solid principles here as well, like activities, with activities and child workflows, delegate as much as you can. And generics, when I write my code, when I'm building platforms, I really love everything to be instantiated at runtime. But one problem with Temporal is it needs to know what classes it's going to use or what classes it needs at compile time. So the way, at least the workaround for this is to create some kind of enums and a registry. So pass in that enum, and at runtime, based on that enum, for example, if enum is ACH, then you can pass in that ACH, and then at runtime, the registry can instantiate the object for you based on your enum type. So that is one thing to be mindful of when you're building platforms with Temporal. And one other interesting thing is data sizes in transit. So there are limits on how much data you can transfer. I think it was 4 MB before, and I think it's much higher right now. But still, there are some limits. End of the day, it's bounded, it's not unbounded. So when you're working with activities and child workflows, you can't be sending unlimited data. So one workaround is, at least that worked out for me, is put data in S3 and send the pointers back work with the pointer, so that way it's easy to work around. And a lot of times, if you're dealing with data itself, worker itself has a limited real estate in terms of resources, right? So you can leverage something like S3 byte ranges. So you can call S3 and have offsets and get, let's say, data from 1 to 100 bytes. So you can do those kind of things too, so you don't take out all the resources or go out of memory. And idempotency is super important, especially in payments. I think there is an assumption, at least not assumption, but at least I've seen that because you're using temporal, it's going to solve all your problems. No, you need to think of your idempotency in payments. So for example, if there's an activity that is, let's say, updating the ledger, you need to make sure you pass an idempotence ID, because if the activity fails and you retry, you're going to double post the transaction. So you need to make sure you have idempotency guarantees built into your system. And temporal is not going to handle that for you. So you need to think about that. And history size is something that you have to think about. There's limited history size with temporal. So if you're doing a lot of polling, for example, that takes up a lot of events. So think about how can you reduce it. For example, if you're doing a poll for every 1 minute, maybe reduce it to 5 minutes if it's not a big deal. So think about your history size. And persist your data in some external DBs, because you're dealing with payments, and when you get these files, make sure you keep storing your data, at least so that you can have them in 7 to 10 years when you need it for audits, etc. All right, so we are at the end of the talk. So some of the takeaways from this talk so far is temporal brings resilience to payments, and you can build full loops for payments. If you look at it, we built a money movement platform, we built a file platform, and we built a reconciliation platform. That is a full circle for how a payment works. And always think about level of indirections, like if you have to back up by a queue to it. If you want to, like there have been a lot of talk about exposing temporal to synchronous request path services. I think it depends on what your SLAs are. So if you want to have a tighter SLA, or if you want to have, if application is latency sensitive, then you might want to add some level of indirection in front of temporal, and temporal can read from that, for example, a queue. And obviously build platforms. Don't build for specific use cases. Always build platforms so they are reusable and save your engineering cost. And we also spoke about some of the temporal workarounds around generics and data sizes. Okay, that's all.